Course Learning Outcomes CLO2 discuss the petroleum system, elements and processes.
Next, from the Karajan types, the hydrocarbon, remember the hydrocarbons and non-hydrocarbon gaseous can be biogenic source from all types of Karajan. So you can see here, this is schematic illustrations that shows the various gases from the different temperature ranges. So this curve shows you a very general way of the relative volume of the gases that came from the organic matter from type 1 and 2 sapropylic source and from the humic source. Okay, remember I did so basically through this illustrations diagram, right? There are three types of gas that will form from the Karajan types. So first is the dry bacteria methane, right, during diagenesis, and then when the temperature increase from 50 to 200, right, there will be wet thermogenic gas, okay, that will be produced, and then lastly, at the same time, there will be dry thermogenic methane that will be produced during the catalgenesis process. Okay, so for during diagenesis, basically there will be bacteria methane or dry bacteria gas that is formed in the surface temperature in the surface sediment from 20 to 80 degrees centigrade. So this bacteria gas is actually estimated to present 12% of total methane in non-reservoir gas and possibly to 20% of methane in conventional reservoir. But this amount of early methane in shallow reservoir can easily lost because shallow reservoir generally will have no effective seal rock. That's why it come up to the surface. So this figure shows the stages of coal formation in which the classifications of coal is according to their degree of metamorphisms or qualification in the natural series from lignite to anthracite. So as we going deeper in depth, the formation condition is depend on the temperature, pressure and the presence of carbon that is preserved in the coal, which temperature will be increased as well as the pressure, whereas the H by C, O by C will be decreased, and also moisture will be decreased. So initially, coal is actually formed by the peat that originated from roots or bark of tree, okay, by bacteria and chemical change. So peat is actually a partially decayed plant matter in swamps and bogs that has a low heat content. So as we going deeper at a greater depth, right, coal rank change. Okay, we'll change from the peat that is not a coal yet, lignite or brown coal, right, and then bituminous coal, soft coal, and lastly is anthracite. Okay, that is hard coal. So lignite here uh, is contains a low heat content, right, and low sulfur content, and it is also limited supplies in most of the areas. Okay. Meanwhile, bituminous coal here is has been extensively used, right, as a fuel because it contains high heat content, and it has also large supplies from most of the areas. Okay, so basically methane forms from the bituminous coal has the highest amount uh, that is generated at temperature 80 degrees, okay, under the low volatile bituminous. Okay, and then we do have anthracite as the highly desirable fuel because of its high heat content and low sulfur content, but the supply is very limited in most of the area. Uh, from the anthracite also, we do found the carbon dioxide, okay, that is dominant in the medium volatile to anthracite and moderate and has been found in moderate amount in the crude oil. Okay. So this is the summary of the origins of natural gas. So this illustrated diagram show the hydrocarbon depth distribution pattern that is repeatedly in many sedimentary basins throughout the world, in which dry gas is actually has been found near to the surface in the immature fascies, okay, during that evolved during the diagenesis process, followed the wet gas, right, in the oil window of the mature fascies, with the temperature occur during temperature within 80 to 150 degrees centigrade, okay, and then dry gas thermogenic methane, it's occur or produce below in the post-mature phases of the oil window between 150 to 200 degree centigrade, right? So in similarity, the heavier gaseous hydrocarbons is actually formed through approximately the same temperature and depth interval as the liquid hydrocarbons, okay, deeper than the bacteria methane, right, but shallower than the maximum formations of thermogenic methane. So to be specific, okay, within this range, right, to be specific, okay, from this hydrocarbon depth distribution pattern, okay, the immature fascies, right, that favor with the digestive process usually contains collagen with spore and pollen particles in light yellow color, indicating that the organic matter has never been thermally altered. So the dominant gases are actually bacteria, methane, and nitrogen gases. Okay. In the deeper fascies, right, in the matured fascies, that actually equivalent to the catalysis stage, right, usually contain spore and pollen that ranging from amber to dark brown in color, that indicating the increasing in temperature is actually helping in cooking the corrosions in the sedimentary rocks. So wet gas and oil mainly occupy in the upper part, okay, of this range, right? Meanwhile, the thermal condensate in the lower part with the carbon dioxide distributed throughout these fascies. Okay. Near to the end of the catagenesis and the beginning of the metagenesis is the post-matured fascies. Usually, if you take samples, right, sedimentary rock from this area, and you conduct palynology studies, right, you will determine that pores and pollen in the corrogen itself is actually going from dark brown to black in color, indicating that the cooking process has eliminated most of the heavier hydrocarbon and form a zones of dominance in thermogenic methane gas or thermogenic dry gas. Okay, and as we go more deeper, right, okay, hydrogen sulfide will be increased. The productions of hydrogen sulfide will be increased, and hydrogen sulfide also only found in the deepest and highest temperature region and serve as the deepest among the natural gas component. So there will be also increasing in the carbon dioxide concentration as well by the inorganic process in metamorphism stage at temperature beyond 250 degrees centigrade. Okay, that's all for the origins of natural gas.